This monster is beyond imagination. Today we take a look at the universe's gravity monsters, so be sure to stay tuned until the end to see the largest and most massive black hole in the known universe with me and how it devours our solar system. If you like it, I'd be thrilled to see a thumbs up and a comment. Thank you very much, friends, and welcome. This video will be massive because it is about the heaviest objects of all. Supermassive black holes are among the most fascinating objects in the cosmos, and one of the largest specimens of all is TON 618. We've often talked about TON here on the channel, and indeed it is an absolutely gigantic supermassive black hole that was long thought to be the heaviest black hole of all. That's how gigantic it is compared to our solar system. The little something in the center is our entire solar system, barely noticeable given the gigantic size of TON. It weighs 66 billion times the weight of the sun. So the dimensions are truly unimaginable, but here's the thing, TON is not the largest mass monster in the universe. In the so-called Phoenix Cluster, there is an even more massive black hole. The Phoenix Cluster is a massive and hot galaxy cluster located about 8.5 billion light years from Earth. It is one of the most thoroughly studied galaxy clusters, and one of its most striking features is the high rate of star formation at its center. It is thought that the supermassive black hole at the center of the Phoenix Cluster is responsible for the formation of so many stars. The black hole absorbs material from its surroundings, releasing energy and radiation that help to concentrate gas and dust near the black hole and eventually lead to the formation of stars. So you could say that this black hole is a kind of stellar midwife.
And what method of birth did you choose?
I'll let the black hole suck me up.
In addition, there are gigantic amounts of hot gas at the center of the cluster. This gas has a temperature of several million degrees and emits X-rays, which is why we can examine the Phoenix Cluster very well in the X-ray range. Here you can see an X-ray image from NASA's Chandra Space Telescope, and the black hole is also responsible for these high temperatures, as it releases heat and radiation that heat the gas. This energy is mainly ejected in the form of gigantic jets, violent explosions that occur in the accretion disk of a black hole. Okay, so far so good, but I can already hear some of you asking in panic,
how gigantic is the black hole?
Very gigantic. It is located in the central galaxy of the Phoenix Cluster, which is called Phoenix A. That's why it's also called the Phoenix A black hole. It is estimated to weigh about 100 billion times as much as the sun. With 100 billion solar masses, this cosmic monster is another 34 billion solar masses heavier than TON 618. Here we see a size comparison between TON, Phoenix A, and the orbit of Neptune. So anyone who thought that it doesn't get any bigger than TON 618 is now proven wrong. Incidentally, the boundary of black holes in this representation is the event horizon, the area behind which the gravity of a black hole becomes so strong that not even light can escape. Phoenix A is truly a gravity monster, and here are some more incredible facts that will blow your mind. Phoenix A is a whopping 24,000 times heavier than the central black hole of our Milky Way, Sagittarius A star. It would take 71 days and 14 hours to orbit Phoenix A. At the speed of light, that's right, at the highest possible speed, you would be traveling for over 71 days, and it even exceeds some galaxies in weight. It is twice as heavy as the Triangulum Galaxy. With the help of the Hubble telescope, NASA was able to take an even better picture of the active core of the Phoenix Cluster, which you can see here. The thought that we are seeing something here that is 8.5 billion light years away is simply incredible. A NASA statement about the image reads, 10 billion solar masses of cool gas are located along filaments north and south of the black hole, probably originating from outbursts from the supermassive black hole at the center of the image. With these unimaginable dimensions, Phoenix A belongs to a very special group of black holes, the so-called stupendously large black holes, or slabs for short. This term is used to describe black holes that are considerably larger than ordinary supermassive black holes. The minimum mass for admission to the exclusive club of slabs is exactly 100 billion solar masses. This makes Phoenix A the only known slab to date. Until recently, in other words, until Phoenix A's weight could be determined so precisely, the whole thing was even just a highly controversial theory. Just 2 years ago, cosmologist Bernard Carr said, "We know that black holes exist in a huge range of masses, so it's only natural to wonder if there is an upper limit. Some people may be skeptical about the existence of slabs because they are difficult to form. However, people were also skeptical about supermassive black holes until they were found. And now the whole thing is as good as proven. Of course, not 100%, as long as we can't take a really direct picture of the Phoenix A black hole, but the evidence is very, very strong. Some researchers even suspect that there could be black holes out there in the depths of the cosmos that have collected so much matter shortly after the Big Bang that they could weigh up to 100 trillion times as much as the Sun. However, the existence of such ultraslabs is pure theory, at least until they are discovered. Be that as it may, we still wanted to destroy our solar system by placing Phoenix A nearby. No sooner said than done. Here you can still see our beautiful Earth unsuspectingly orbiting the Sun, and now we place a black hole next to the solar system whose masses we now increase to 100 billion solar masses. And bang, Phoenix A is there. Well, that doesn't seem to agree with the solar system too well. All the celestial bodies, including the Sun, disappear behind the gravitational maw. Incidentally, we also saw an effect here called gravitational lensing. The gravity of many black holes is so strong that it affects the light particles that reach our eyes from the cosmos. This causes the bizarre distortions that we have just seen here. Astronomers can even take advantage of this because we can use black holes to see into areas of the cosmos that we would not be able to see without their gravitational lens. We have just heard that from a purely physical and theoretical point of view, slabs could exist with a mass of 100 trillion suns. I had fun placing such an ultra slab next to Phoenix A. Compared to that, it really does look absolutely tiny. Now we just need a suitable name for our 100 trillion solar mass ultra slab. Be sure to write your best suggestions in the comments. I'll take one of them and use it to name the black hole. An exciting theory about black holes is that our universe could be inside one. And a variation of that is that every atom contains mini black holes, which in turn lead to a new universe. So is our universe perhaps just an atom? You can find the answer in the video shown, and I'll give you this much away. It will leave you pretty speechless. If you want to support the channel, then also feel free to browse through the older videos where you will also find super exciting topics and support the channel. Otherwise, I'll see you in the next video. Take care, friends.